So, today we're doing 14.1. This is the second to last lesson of the year. Woo! Yeah. Tomorrow we'll be doing 14.3. Yes, I said 14.3, not 14.2. We don't need to do that one, not for this one, because we're just doing introductory type stuff, kind of preparing you for next year. So, if you don't get half the stuff, I'm not saying it's okay, but you're going to get another chance to do it. Friday, writing final. Monday, review for test. Tuesday, test. And then from there, seniors you test, and then everyone else reviews forever. So we'll get plenty of review time in. We'll have about 4 days, I believe. Okay, so let's do this. So we've already talked about the 6 basic trig functions, right, Shauna? Thanks for closing that laptop. We've talked about sine, cosine, tangent, secant, cosecant, cotangent. I also showed you guys some kind of different ways to write the secant, cosecant, cotangent, right? Secant could be written as 1 over cosine. The cosecant is 1 over sine. The cotangent would be 1 over tangent, right? I'm going to give you another list. They are in your companions, and they're at the very bottom of page 374. They should look like this. If you don't have one of those books, grab those cell phones, take a picture, because you're going to need to reference them regularly. I know that when I was first learning it.
Can I write it down?
If you have them in your handbooks, then you can copy them over. Okay? Just because I want to make sure that I have plenty of time to cover this and answer any questions you might have. Because remember yesterday we were pressed for time. So take those pictures. We can come back to those. I'll show you what they are.
That's because we had a big old long conversation.
We did. We had some really good conversation yesterday. So if that happens today, then we have time for that. Okay? So these are just notes. Again, they're just static. You can do them at home, on your paper. Find 2 minutes, right? 2 minutes that are precious in here. All right, we're good? I'm gonna add a slide because I want to talk about this real quick. So in geometry, there was this really popular property that we used to use. Actually, it was a theorem. And it had to do with triangles. You guys remember that popular theorem? Yeah, Pythagorean theorem, right? What did Pythagorean theorem say? Whoa, what was that? Well, I didn't want to do that. I want to do this. Did I give the answer away with that slide? Son of a biscuit. Let's go back to here. So, we are not doing geometry. We are doing trigonometry, right? So here's what I want to do. I want to go ahead and draw this triangle here for us. Now, we don't know what theta is. It doesn't matter what theta is because what we're after is going to be an identity. Now, this is a 1-unit circle, which means that the radius has to be how many units? This is a 1-unit circle, so what should the radius be? 1. So there's 1. Now, what's the other name that we gave x in trigonometry? We also called it not the base. You're thinking of the triangle. We're talking about the x values here. Starts with a C, ends with an O sign. Cosine. We call this cosine, and we called the up and down one sine. So we have this here going on. Now, if we took the same idea from geometry into trigonometry, then we can also create a property. We can say, oh, well, then that means that cosine squared plus sine squared is equal to 1 squared, which is just 1. And actually, I'll write it as, that doesn't matter. How did they write it in this slide? Cosine. Good. Okay, so there it is. So guess what this is called? That is called the Pythagorean trig identity. Okay, so it's still the same identity, a squared, b squared, c squared, except we're using our trig values there. That makes sense?
Can you spell that out?
Spell what out?
What do you do with that?
Pythagorean identities? Right there.
I didn't see that.
It's called Pythag. We do that Pythag right there. I'm on my way. Okay, now there's 2 more up there, isn't there?
That's weird.
Yes, they're all squared. Now these should also be in your handbook, so don't spend too much time copying these over. But you see the first one makes sense, doesn't it? Cosine squared, sine squared equals 1. What about the other two? Where did those come from, right? Huh? Okay, so I'm going to show you exactly where they came from. I'm going to take this first one right here, and what's it say? Cosine squared plus sine squared is equal to 1. Now, we know, excuse me, we know from algebra that we can do whatever we want to one side of the equation as long as it happens to the other side. Okay? So here's the first thing that we can do here. I can actually divide everything by cosine square. Now, why would I do that? I don't know. We like math, and we just want to mess around with some stuff. But we could do that, couldn't we? As long as I do it to everything else. I did it to both sides. Now, here's my first question. What is cosine square over cosine square? That just is 1, isn't it? Next question. What is sine over cosine? What is sine over cosine? Oh, we just had a whole page with these, didn't we? Sine over cosine. Where did that page go? Is this one? One before? I deleted it. I think I deleted it. Sine over cosine is how much? It is tangent squared. And then 1 over cosine, we would call that. That's 1 over cosine is the reciprocal of, it's a secant value, isn't it? So this becomes secant squared. Oh, this is that formula right there. That's where it came from. All they did was divide everything by cosine. Guess where the third one comes from? Instead of dividing by cosine, everything got divided by sine. Got divided by sine. Thank you. Just crank. Okay, you can catch us on YouTube. Smash that like button. Subscribe. Hit that bell for those notifications. So, you guys good with those 3 properties there?
How'd you get the 1 plus tangent?
Well, what is cosine over cosine? Anything over itself is 1, right? Now this, that's the definition of tangent. It's sine over cosine. Grab your book. Let me see if I can redo this, because I think I deleted that slide. I shouldn't have. So I'm going to do this real quick. Open 14.1. No, I don't want to save changes. Okay. Okay, so here's tangent. See it? It's sine over cosine. And then cotangent is simply that reciprocal of that, cosine over sine. All right? So there's your identities. Now let's do some of this for real. Now here what they want us to do is to talk about the domain of validity. The domain. That's all they're really asking for. I think, they're talking about the domain of validity, but they're just talking about the whole thing itself. So here's what we want to do. You're going to want to make sure you have your calculator with you. Oh, what is that? It's clear. Clear. Here's the simplest thing that I can tell you. Let's take a look at, what was it, the one side of the function? Here we go. Cosine. Can you guys think about the cosine function? What was the domain of that? It's all numbers, right? It didn't matter. Now I'm just going to show you visually. Here is cosine x. Let's go ahead and let that graph. So here's cosine x. So are there any issues in the domain with x? There aren't any, right? So the only thing I need to worry about is going to be the other side. So I'm going to take a look at the other side. That is 1 over secant theta. Okay? I want to be careful with that. So I'm going to graph the secant. Because if you think about this, this is going to be 1 over, what is it? 1 over cosine. So I want to make sure I graph that secant graph. Let's get back to secant. So I'm going to go y, and I'm going to graph, to graph secant, I graph 1 divided by cosine x, right? Because that's the reciprocal of it. And let's take a look at this guy. So here I'm going to have some issues, aren't I? Can you guys see that there's issues on this graph? Where are the issues? Where are the issues? Where am I going to have problems? the asymptotes, right? You see, if I got rid of, let me get rid of this blue one so you can see it, because we know the blue one's fine. So let's get rid of the blue one, which is the top one. Let me clear that and just show you the 1 theta. See how that shoots off to infinity on this side here? That means that this here, even though we don't see it, what do we call that bad boy? He's an asymptote, right? It's never going to be in there. So we have an asymptote here, here, here. We got one here, and we got one here. So, looks like we could be just about anything except for those specific points, right? Does everyone see that? We need to figure out what those points are. Now, I've already made the window so that it looks nice here for me. Let me go over to window. And what I did for my window is I went from negative 2 pi, negative, oops, not negative L2. I went from negative 2 pi, what am I doing? Second pi. That's negative 2 pi. That is this value right there, the 6.28. So it's going from negative 2 pi all the way to 2 pi. And this intersection right here is actually pi halves. So every tick mark, my friends, go back to the graph, is pi halves. Okay? So this is pi halves. This would be pi. This would be 3 pi halves. You guys see that? So, where am I going to have the issues at? I've labeled where I have problems, which is the asymptotes. All I need you to tell me is where those are at. Yeah, that's all that is, right? And all the what? This is negative pi halves. This one's the negative 3 pi halves. And we know that this pattern just repeats itself, right? So that's what I'm asking is, where am I going to have these issues? And there's going to be a general way that you can talk about it. If you notice, this is really 1 pi half, isn't it? So I'm going to have a problem at every odd pi half. That means 1/2 pi, or 1 pi half, 3 pi halves, 5 pi halves, 7 pi halves. I thought about that for a second, didn't I? 9 pi halves. So all the odd ones, guess what's going to happen? I'm going to have an asymptote there. So when we talk about the domain of validity, like this is saying, then the only time I'm going to have problems is with the secant graph, because I know it has asymptotes in it. And according to the graph that I just made, it happens every odd pi half. Not the even ones, because this would be 2, right? 2 pi halves. And then over here would be 4 pi halves. And I'm good. But I'm not okay on the... Huh? Aw, thanks. All right, cool. Let's continue. Questions on here? Please ask them if you have them. No? We'll continue? All right. So you are now starting to see why you really need a calculator, right? I'm going to grab these. All right, here we go. Are we going to have issues here? I am. It's pretty much the same thing, isn't it? Where's my secant this time? It's over here. Do we have issues with the secant? Yeah, the secant is going to have asymptotes. Where? At the odd pi halves, right? Or every other pi half.
Is that a rule?
Pretty much, unless it's shifted. Yes, it's a rule. Unless we add an h, then yes, it's the rule. That's the way it's graphed. Does that make a little bit of sense there? Okay. All right, let's take a look at another one. Okay, this one's a little different. This one's sine now, right now. Do we have problems with the sine graph? No, sine graph is just a nice wave, goes on forever, right? The one I want to worry about is that cosecant. I want to worry about that cosecant. So I'm going to have to graph this cosecant. Where's my calculator? And see what happens with the cosecant. Let me clear this ink. Clear ink. Y. And instead of having, oops, instead of this being a cosine, it should be a sine. And I'm going to graph that. It's going to look very similar, right? It should look similar to the secant graph. But this one's a little different, isn't it? This one is shifted. Where are my problems at?
Pi, 2 pi.
At all the pi's, isn't it? It's a problem at all the pi's. Because this is pi half, this is pi, I'm going to have a full turn here, and then I'm going to have an asymptote here at 2 pi. So it's going to happen at pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So all the pi's will have asymptotes. So I can say for my domain of validity, I can be everything except the values for pi. Make sense? Click, 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 a little bit. Oh, yes. When?
Friday.
Tuesday. Tuesday. What are we doing Friday?
Final.
Writing final. All right, let's get to some fun stuff. Those domains are just, you just have to find them. Okay? Now, this is the fun stuff. I really thought this was entertaining for me because they're like little puzzles. And I gave you all the rules, right? You guys know, you have all those trig identities from the beginning. What sine can look like, what cosine can look like. That's all we're doing, and we're just playing the math game. You guys ready to play the math game? Actually, this would be the trig game. Here's what they're telling me. They want me to prove, because see, this is an equation, right? This is saying, you know what? The left side is exactly the same as the right side. Do we agree to that? This equation up there says the left side is the right side. Right? I mean, they're telling me that. And what they want me to do is to prove it. You guys ready? Sophia?
Yeah.
So here's what we're going to do. Can you guys see that okay? Should I make it a little bit bigger? Is that better? All right, so let's see here. I know that sine, and you know what, guys? I don't draw these thetas. They distract me. They distract me. So if you don't want to write them, don't. At the end, put them back in. I know I'm probably like breaking some kind of math rule, cardinality, or I don't know, the holiness of math, but they distract me. I can get the same results without drawing those thetas. Okay? So when we're doing these, don't do them. Here's my sine. I'm going to write secant in the form of a sine cosine, because then I can see what I can do, okay? Now, how can I write secant in the form of a sine or cosine? It's 1 over cosine? 1 over cosine. Very cool. All right, so if I multiply the two, I'd be doing sine times 1, which is sine. This has a denominator of 1, so 1 times cosine is cosine, isn't it? Oh, wait a minute. This is a rule. What is sine over cosine? Tangent. Baya. Guess what I just did? I just proved that they are the same. Yeah, yeah? Yeah, yeah? Yeah, yeah? I feel so bad. You guys are like worn out.
It's hot.
Yes.
It's freezing. How are you cold? It's 103. It's cold in here.
In here it feels okay. I'm not feeling hot yet. Even though I was running right now, trying to get back over here to school you guys. You don't have a jacket? See, that's why I like cold. Cold, I can put a jacket on. I can throw on my sarape. But when it's hot, there's only so naked you can get. Right? Like, I can't get more naked than this. It's like, oh my God. So cold, man. I'll throw on some undies, those long johns, a jacket, my sarape, maybe one of those snuggies, I don't know. And you can be warm, but oh, you can't get on the other end. All you can do is go down to Walmart and shop for meat all day.
Ew.
Right? It's nice and fresh here. Oh, look at that cut of beef. All right, can I change the slide now?
Yes, please.
All right, let's check this one out. Very similar to the one we just did, yeah? So I want to prove that the left side is the right side. You guys want to try that, or should I do it too? I should do this one so you get a little bit more comfortable. Here's what I know. I have 1 over cotangent. Wait a minute, cotangent. Do I have a definition for cotangent? It's cosine over sine, isn't it? It's cosine over sine. Yeah, this one, let me use some color. This one is this one. And then all I did was rewrite cotangent as its definition of cosine over sine. Okay? Now, do I really divide by fractions? No, what do I have to do? Multiply by the reciprocal. So I'm going to multiply sine over cosine. This is gone. 1 times sine over cosine is sine over cosine. Oh, wait a minute. I saw that definition a minute ago again. Sine over cosine is just tangent. And guess what I just did? I just proved that that is a true statement. Trig. Getting tricky with it. Na 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 na. Na 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 na. Na 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 na. You gotta love Will Smith. Will Smith is the best. I'm so jealous of you, dude. I was looking at that school some more. That's like the place to be. You know what? You know how I picture that? Like every show, TV show that they show, like the cool school, that's the spot right there. Like they probably film a couple of shows there too, huh? Man, I don't know if I can handle that cold though. Yeah, I could. I think I still got another Snuggie in my truck. Can I change the slide? Yeah. All right. Ooh, this got good. You guys try. You guys are good. Me do?
Yes.
Me do?
Yeah.
You know what? Let me give you 30 seconds. See what you can do. Give you 30 seconds. See what you can do.
I can't foretell the future. Nothing.
Look at those definitions you got. See what you can do. Now, like I said, here's my suggestion. Always first try to write everything in terms of sine and cosine. That was what the trick I had. And then from there, I would go and try to manipulate things and see what I can do with it, okay? All right, y'all giving me some looks. Y'all give me some looks. So, here we go. Cosecant, that's the reciprocal of sine, isn't it? So, cosecant is 1 over sine. And then in the denominator, I have secant. What is secant? That is 1 over cosine, correct? Now, do I really divide fractions? No, I multiply by there. So this is going to come to the top, and I'm going to multiply by cosine over 1. This is gone. So 1 times cosine is cosine. Sine times 1 is sine. Oh, wait a minute. That is the definition of cotan. So I'm done. See what I did? I always convert everything to sine cosine. Not tan, just sine cosines. And then see what happens, what I can do, and things usually work themselves out. Okay. The only thing that I would ask for here is like a small lake to go fishing.
Well, ice fishing.
I know, dude. I'm so mad at you. I'm telling you, dude. He could do anything he wanted. Oh, with the little hole, you mean, like in Alaska?
No.
You've never been in snow? The first time I saw snow was in St. Louis, Missouri.
I mean, I've seen like I've driven to Flagstaff like once or twice, but I've never been like snowfall. Like,
And that is the only place that I've ever seen in my life fireflies. We were like, what is this?
What, in Flagstaff?
Yeah, no, in Missouri, St. Louis. They're beautiful. Have you never seen fireflies? Yeah, we were like looking out the window one day because we didn't have TV, we were bored, just watching, and then we saw these little lights just like,
They're so beautiful.
whoa, 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 whoa. My brother's like, what is that? We had to catch one. We did. And we stared at that thing for hours until this light went out. I know. Then we let it go. I'm sure it got better. Need some honey. But yeah, like we just stared at it like all night. And then his light was started like going to sleep. We're like, oh, I think he's ready to go. Bye,
I was going to sleep.
it was probably going to sleep too, huh? But yeah, it was amazing. Like we weren't even tired. Like that was our TV. It was amazing. They're just beautiful to watch. And when you see a bunch of them together, you gotta find that. That's amazing. That's like movies type stuff. Things you see in the movies. All right. Now we're gonna keep doing the same thing, but now we're gonna level it up a little bit, the difficulty there. Okay. Here, check this out. Oh, wait a minute. You guys can do this one, right? Can you prove to me that the right side is the left side? Prove that the left side is the right side, just like before.
Wait, how do you think?
I'll let you guys mess around with that a little bit. I like to move it.
Did you know it was Tristan's birthday today?
T-Will? I didn't even congratulate him. I had to leave. But yeah, I did know. I'll say on the video, congratulations, T-Will. Sapo verde to you. Let's do this. Sapo verde to you. You know Sapo verde? That's when we Latinos can't say happy birthday. Happy birthday, Sapo verde. Sapo verde to you.
Happy birthday, but like obviously like a little accent, like happy birthday.
Yeah, well, Sapo verde is the extreme. Is the extreme one. Many years ago, we were listening to the trick or treaters. Y ven los plebitos. Tricky tricky. Tricky tricky. Okay. No tengo canels. Oh Lord. All right, what'd you guys do? Any ideas? Any ideas? What is secant? What is secant? It's 1 over sine? 1 over cosine. I'm just going to make a note of that over here somewhere. So I want it to become, I want this left side to become 1 over cosine squared. What's up? I'm just making a note because this left side is that, technically, right? So if I can get to that, I know I can just write it, flip it, and make it a secant. Does that make sense? So let's see here. What can we do? I know that this is 1 plus sine square over cosine square, correct? Because that's tan, right? Sine over cosine? Let's think about this. There's only one item on the right. There's only one item on the right, but there's 2 terms on the left. So how can I make 2 terms become 1 term? I could cancel, or I can just combine them. And it does say plus, right? So I want to add these, don't I? How can I add these? Well, what would I need? A common denominator. Now here's the beauty of 1. I'm going to rewrite 1 to look like this. Cosine square over cosine square. And that's plus sine square over cosine square. I can do that, right? Can I write cosine square over cosine square? Isn't this just 1? That's all I did. I did it because I was lazy. Because I know that now the denominators are the same. You catch that? Pretty lazy move? Sorry. Math don't like hard. Alright, my denominators are the same. That means that my denominator is cosine square. So what I have up at the numerator is cosine square plus sine square. Oh, wait a minute. Anybody recognize that numerator? Anybody recognize that numerator? Oh, that's that Pythagorean identity, huh? Which one is it? Let's see here. Here. And what does cosine square plus sine square equal? It equals 1. So, that means that I'm just going to make this into 1 over cosine square. Wait a minute. Isn't that what I wanted? Yeah. So guess what this is, people? That is simply secant. Trig. Pretty cool? Yeah, yeah. I tell you, this is fun. It's fun till Daddy takes a T-bird away.
Trying to conceal your brows.
Huh?
Trying to conceal your brows.
No, I sprayed myself somehow. I've got like water droplets right on my brow. How was that? We follow that? Questions on any part of it? Shana Lashana? Chana Chana. Don't be stingy. He's all our God. Can I change the slide? Yeah. All right. You guys want to try now? You can do it. Give you guys a few seconds. Give you guys a minute or two, yeah?
So that zero thing?
Huh?
What does it do?
What zero thing?
The beta.
Oh, that's a theta. That just means it's the cosine of
beta?
some angle. Theta. I ignore it.
So we don't need it.
You technically do at the end, but like I said, I ignore it just when I'm doing this because I'm not calculating, I'm not graphing it or anything. Time after time,
Oh, God.
be right there. Huzzah. Yes.
So one is always cosine? Like just one? Like,
What's up?
one, it's cosine.
One is cosine?
Well, like you did it, like just one, is cosine.
It was cosine plus sine squared.
Oh yeah, but it was cosine though? Or no?
You can do sine plus cosine if you wanted to. It doesn't matter because addition is commutative. Right? 2 plus 3 is the same thing as 3 plus 2. Oh, wrong mouse. We're talking about this part right here?
No, the cosine over cosine.
Oh yeah, you can make it whatever you want. You can make that tan over tan,
Oh, okay.
sine over sine,
Okay.
pi over pi, e over e. Anything over itself is a 1. Is this where we were at? Cool beans. Cool beans.
Sorry. Oh, I just noticed the Junie B. Jones musical thing.
Junie B. Jones! My little girl loves Junie B.
That's the only book I would ever read is hers. Like,
You read her books?
Yeah.
I was going to buy her a set.
Didn't she choose like the bad kids?
Yes! I'm so upset still. Like, and I keep looking for it. And next time I'm just going to choose for her. But she does have like the set for Amelia Bedelia, Nancy Clancy. We have the, what's that one movie that just came out? With Oprah? Wrinkle in Time?
Oh.
I have the whole set of that for her. It's a little bit above her, but not by much. I just found out she's at a 3rd grade reading level.
What grade is she?
First.
Oh,
I said,
Not a genius.
just like her mama. Not like her daddy.
you said she has Amelia Bedelia?
Yeah, she has Amelia Bedelia.
Yeah.
She got a couple sets, so she got that Bat Kitty. Then there's another one that has a bunch of shorts in it. Like, yeah, they're all Newbery winners. Because you know you got to get that Newbery medal on. Tell me what to write.
Oh, never mind.
No, don't. That's the best part right there. What'd you do? What is it? What'd you get for one? You can't just tell me the answer. The proof is the answer. All the steps is the answer in this case. So what'd you do with 1?
Made it sign.
You made a sign? Here's your sign. What'd you do? Just sign by itself or sign square?
Signs. Yeah.
You just sign squares?
Yeah.
And then
And then plus cosine.
that's cosine
Squared.
over
Sine.
sine square. And that equals cosecant square. And then what'd you do? Huh? You're good. Keep going.
And then,
So you combine them.
yeah.
Denominator being
Sine.
sine square.
And then sine squared plus cosine.
And then sine square plus cosine square. And then you said, oh, that's just 1. So sine square 1. And they said, oh, that's the definition of cosecant squared.
Did it right.
Yeah, so in this case, guys, you can say, oh, I have the answer. But that's not the answer here. This whole process is the answer. Because they're asking us to prove. And remember, we've been doing those 2-column proofs? What'd you do first? What'd you do second? What'd you do third? There it is right there. That's the whole proof. Hmm?
How do we show that in math Excel?
It'll probably have like slight things. We'll see that. There'll be steps. It'll walk you through probably. What should this look like? What should be the next step? You know, the next part of math should look like this, and all you'll do is reference what you have here. Or they'll give you suggestions, and you'll say, oh, that one works. And you'll see like, oh, cool, I didn't think about it that way. This is going to be fun. I think it's going to be fun. I think you will think. Mr. Moon is just crazy. All right, you guys ready to go on? No?
Where's the bottom?
1 over sine squared. Sorry. The lower it goes, the uglier it right.
And equals.
Yeah, this is the definition of cosecant square. I did it! I did it! All right, we're good now? Okay, so verifying identities. We're still doing that. Did we already do these? Oh, that's a challenge.
I just understood all.
Well, it's the same thing. It's still the same thing. Prove that the left side is the right side.
Yep, they both
It is.
equal 1.
Oh no.
No, they don't.
Damn.
Gosh darn it. So here's what I'm seeing. You see how the other side is a, what? Now let me walk you through this one, okay? Because this one's a little bit tougher. So you got to see some stuff before you can do it yourself, okay? So here's what I'm going to do. What do I always do first? Switch everything to sines and cosines, right? So tangent is sine square over cosine square minus sine square. Now, here's my dilemma. The right side is a multiplication problem. The left side is a subtraction problem. So there's the dilemma. I got to be able to somehow switch this so that I'm multiplying 2 things. So I've written everything in sine and cosine. Oh, do you see how they both have sine in there? Guess what I can do? Starts with an F. Yeah, I can factor out sine squared. That would leave me with 1 over cosine square minus what? 1. Oh, I love those 1s because I can do whatever I want with 1s. So here's what we got. Let's see here. So I've got sine square. This is going to become a denominator of cos. Oh no, I don't want to do that yet. Big screen. You guys can see what I'm doing. So I'm already thinking ahead. I'm going to go 1 over cosine square minus cosine square over cosine square. You guys cool with that? Right? So here's what. Oh, this should be square. So now I have sine square. My denominator is cosine square. And then the numerator, I've got 1 minus cosine square. Right? Any questions at this point? You're okay with the 1 becoming cosine over cosine? And then they have the same denominator. So it's just cosine there. And then it's 1 minus cosine squared. That's all I've done. Okay? Now, what to do, right? I'm kind of stuck here. Anybody stuck? Anybody got ideas for me? Huh? Breaks automatically? How do I bring sine back in? Oh, I could, but remember, this is This is two multiplication things. So maybe I can't do that yet. But here's what I'm thinking. Here's what I'm thinking. Say that one more time.
You got cosine over cosine, so that just one.
Well, yeah, that's because we came from here, right? Do I want to go back to that? No. But let me give you guys a little clue here. I recognize these two pieces here. I've seen them before. I've seen them in the Pythagorean theorem. That was cosine squared plus sine squared equals how much? 1. And if I did minus cosine squared to both sides, do you see it now? Do you see it right here? 1 minus cosine squared? Guess what 1 minus cosine squared equals? Sine. So, this thing that I circled in red is now sine squared over cosine squared. I want to take a look at what we need up here. That's tan. There it is. Do you see it? Because what is sine over cosine? It's tangent. So now I have sine squared times tangent squared. And if I want to make it look exactly like the other one, I can just swap them. Because I know that multiplication is commutative. And there it is, my friends. Woo, that was pretty. That was pretty. It's nice.
Oh.
You guys want me to change it back to the bigger size one? So switch it back then? Boom. Where's your questions? Go up? Here? A little bit more? Or just start at the top first? Sorry. Okay, so here, you guys tell me one to... Five horn quant. British recognized bands. Tractions for accomplishments. Gotta rally up the Brits, guys, on Friday.
For what?
For dance, band, softball, track.
You can scroll down.
Scroll down, guys. You guys good? That's the rest of it. ¿Estaba chida, verdad? He's nice. That's fun. That's nice right there. You know,
What time is the rally at?
2:50. Are you gone?
No, I have Fitzgibbon. She's not going to let us go.
She has to.
She doesn't let us go till 3. She didn't last year.
It's at 2:50.
She wouldn't let us out of the classroom till 3 because she wasn't sure if it was happening or not, even though there was an email.
Well, it's happening. All right, you guys ready for the next one? Say yes, Mr. Munoz. I can't wait. Here we go.
Oh boy.
Oh boy, oh boy. You try. You try. Give you guys a minute or two. You can do it.
I can write it down.
I don't know. It works sometimes and sometimes it doesn't. It's not. You could always just go around this. Even if it's on. You can go around. I would say for next time.
I was just asking her.
Oh, because you wanted to get this right. That's nice. see those pencils movies, which means you're probably done. Or you quit. Don't do that. That's not something to get excited about. Come on, man. Perseverance. Push, push, push through. No? You want to do it? Want me to do it?
Yes.
Alright. I want to get the left side to just be tangent, right? Now, right off the bat, do you guys see they both have secant? They both have secant, don't they? For now, I'm gonna factor that out as secant squared minus, not minus, what am I talking about? Secant squared, and this will become 1 minus cosine squared. Do you guys remember what I did with 1 minus cosine squared? What did I convert that into? Sine. So this is, and I'm going to go ahead and convert this as well, because secant is 1 over cosine squared, and then I can convert all this into sine squared. Oh, look at that. Sine squared over cosine squared. That was easier than some of the other ones, wasn't it?
Yeah.
You.
I quit.
No, don't quit.
I don't.
It just takes time.
I don't remember all the things.
I know, and that's the thing is, I've got years on you, so I have it memorized. I know what to do.
Sorry.
I swear. What?
No, it's not good.
Well, here, think about it this way. You've got a head start on next year.
Do we? Because I'm pretty sure I'm good with it.
Because this is going to be, next year is really called Algebra 3 trig, isn't it? It's not for, trig not for one chapter, trig for one semester.
Just one semester?
Yeah.
And then it's easier? Or?
No, because you'll do algebra semester 1 and then you do trig semester 2. So, it will only get harder.
I like algebra. I don't like geometry.
I love geometry. But you know what? Here's something that I've realized over the years.
I wish I could
There are
take
two types of
it.
people. There's your algebra people, and then there's your geometry people. There are people that will just love geometry and can't do algebra. And some that just love algebra and can't do
And
geometry.
there's
I
this
love algebra.
I like it all. I'm just a geek. I love me some Geo. Geo's amazing. It's so fun. It's just like, it's in
I couldn't
space.
understand my teacher last year, so I didn't really learn much.
But you're getting this, right?
Yep.
Most of it. I'm about 80% there, Mr. Munoz. It's all good. You guys ready to do some more?
I've always been bored.
There's still more? It's almost done?
It's just more of the same. These are probably even simpler. All we have to do is simplify, right? So to simplify, like I said, change everything to sine cosines. What is this right here?
1 over sine.
This is 1 over sine. See, you're getting fast already. What's tangent? Sine over cosine. Oh, what happens with these guys? 1. So I've got 1 over cosine, aka secant.
Well, you two said.
I was like,
You blinked.
Are we allowed to use
The answer to that is the first 2 letters of what you asked for. No. I'll do this again. I know that cosecant is 1 over sine. Tangent is sine over cosine. Sine and sine will make 1. So I've got 1 over cosine, which is also called secant theta.
Mr. Munoz.
Yeah?
I was asking my friends that have it to help me yesterday on the homework, and they all kept saying, why didn't you give us a circle with all the things on it?
Because you can't use it. You won't be able to use it on your final exam.
What do you mean? Yeah.
And I gave you other things, didn't I? I gave you the finger thing. Remember that?
I forgot it.
That's all of them. And then I gave you the 2 triangles, which is the 45, 45, 90, 30, 60, 90. You know anything other than that?
I don't understand.
That's all the unit circle thing is.
I don't even know what the circle is. I don't
Here, I'll show you what it is. If you go to the internet and search unit circle, here's going to be the problem. They're used to using this, and all the answers are being handed to them. And then when they take a test and they can't use this, guess what they're going to be crying for? They're going to be crying for this because they won't have it. But they're going to become dependent on it. That's what they're telling you about the unit circle. But that's all it is. It's radical 3 over 2, 1 over 2, radical 2 over 2, radical 2 over 2. It just gives all of them in a cheat sheet. The problem is, though, when you take your test on Tuesday, what are they going to do? I know what you're going to do. 45, 45, 90, 30, 60, 90. We're good? All right, that's it. That's all I got.